Hello, today we are starting our new office hour. It starts at number 79, since we are coming from our community meetings to an office hour where we are changing a little bit the format. And the name of this session today is 101 What You Might Not Know About Fluent Bit. And before getting started, we want to thank our principal sponsor, which is Chronosphere, and my current employer, for supporting these initiatives and supporting the development of FluentBit. My name is Eduardo Silva. I'm the creator, maintainer of FluentBit. I have been around the CNCF and Linux Foundation for a while, so I'm a bit familiar with the project and the ecosystem. And these office hours aims to be a bi-weekly space to connect with community members and also have a way to record our content as educational lesson demos for the community. And the format will be around knowledge sharing, open Q&A, or contributor guidance. We will try to evolve this a little bit every other week. But as of now, before today, we were focusing much on PR reviews, and now we will try to focus more on knowledge sharing and different areas of the project that you might not be aware of. So what you can expect. So on every office hour, you might expect short talks, walkthroughs from maintainers, users, insights from the community, tips and tricks, observability, and the chance as well to ask questions and to get unblocked on different stuff. The ways to participate is in our agenda. Yeah, in our agenda, usually every 2 weeks, we will have a basic idea of what we're going to share, who's going to present, and you can add your own comments as well, or you can come back to that document later in case you want to get some reference or you want to learn some about specific topic and you were not able to participate. You will find the link to the video that will be uploaded on YouTube and others. Or if you want to volunteer and participate, that it's great as well. Okay, so let's get started. I think we have been using these slides recently to try to explain the problem we are talking about on 101 today. And 101 is like in infrastructure, the volume of data, it's a problem, right? Data is growing year over year. And your goal is always not to just process data. Actually, your real goal is to perform data analysis. But in order to get data analysis, you need to get that information in some place so you can run your own queries and analyze them. However, in reality, the data comes from different sources, different formats. And if you want to do analysis, it might become a little bit a challenge, right? And in a world where we have distributed systems like with microservices like Kubernetes, right? In order where we have an environment that is scaling up, is scaling down, getting all this telemetry data can be a challenge, even in more demanding seasons, meaning like you have more requests to your own services, your services are generating more and more data. So how do you perform data analysis? And of course, the more data you have, your performance in terms of the time that you get in order to retrieve that information and be able to process it might delay a little bit. The whole point is how do we collect sources with destinations so we can do data analysis? And that is Fluent Bit. It's a telemetry agent that is part of the CNCF that allows you to collect data from different sources like a Kubernetes log file, systemd, Prometheus metrics, OpenTelemetry over OTLP, syslog messages from firewall, and be able to process that information and send the data out to any type of OpenTelemetry collector or a backend to store the data and do queries like OpenSearch, Elastic, Splunk, and so on. And FluentBit is driven by a few key principles that exist that it has always been developed with performance in mind. We want to make sure that this project can scale up with the new demands of data volumes, right? So we try to optimize for speed, for efficiency, and try to process data really fast, but as well consume less CPU and less memory over time. It's a vendor neutral solution that allows you to integrate different type of solution. It could be an APM, a specific vendor that provides the source of information, right? We aim to integrate with them. So it doesn't matter if you're using, for example, Splunk, Auto Collector, or Elastic, or you have a mix of technologies, the goal of Fluent Bit is to be just a plug-and-play solution in your environment that speaks multiple protocols and can deal with multiple type of scenarios. And from a broad ecosystem support, Fluent Bit has a pluggable architecture. That means that if you're using some special service that you need to connect to Fluent Bit, you just can write a plugin. Today, you can write those plugins in, well, Fluent Bit is written in C language. It could be in C. It could be, we also support Golang. We support WASM, and Zig language is coming up as an experimental mode today. So it's kind of versatile in terms of what you can do and accomplish with it. And as I said, Fluent Bit is part of the CNCF. It's together with the Fluent D project in a graduation stage. And today, well, a part of the journey is like we have been around for almost 10 years. So this year is 10 years for the project. Well, since the Fluent Bit was created, when Fluent D, the parent project, joined the CNCF, Fluent D got graduated, and Fluent Bit as well. And Fluent Bit over time got more than 40 million downloads. Well, 3 years ago, we are in order of billions today. And it's widely adopted by different cloud providers like AWS, Google Cloud, Alibaba, Oracle, and Microsoft. Okay, so when talking about data, and specifically this data comes inside what I call a category, right? And we call those category signals. Everybody's familiar with logs. Even when you were testing out your new programming language, you were doing your printf. And that printf used to say, hey, printf, hello world, or print hello world. So this is how to get started. Now, in infrastructure space, when you have an application that writes hello world, right, that may become a log. It's an unstructured message that is sent somewhere to the system console, or if it's running under a container, yeah, this will be stored inside the container. So logs are kind of structured messages. Imagine like it's like a JSON, but with a bunch of key value pairs with different type of data types. And we have traces, metrics, and as well profiles in experimental mode. We're going to talk a bit more about them in a little bit. So logs, while they have, well, they don't have a schema in our world. They have structure, but doesn't have a schema. So, but what they have a common patterns, right? One of them is a timestamp. That means when this message was generated, some metadata associated with it, and the record. And the record itself can be anything. Just imagine a JSON map with a bunch of key value pairs, right? And if you write in your application hello world and this runs in a container, yeah, you might get this final representation, which is kind of augmentation with the metadata, which is the timestamp and other type of data that can be associated with the application that where this message was generated from. When we talk about metrics is a bit different, right? Metric is a type of signal that says, hey, this represents a numeric value for something. And metrics are quite specific. They have a timestamp, have a name, and a type. And type of metrics could be counters, gauges, histograms, and they have a value. And the most simple example, imagine that you want to measure the temperature in your room. You're going to use a metric, right? Where you know that the name of this metric will be temperature. At some point, you're going to measure what's the current temperature and generate that metric. And that metric value will be, in this example, 24, right? And the good thing is like it will be a gauge because temperature can go up, can go down, depending on the time of the day. If you have the AC, turn it on, turn it off, right? In other cases, you have counters, which means like, hey, for example, every year you're getting older, right? 1 year, that's like a counter. You're never gonna get less years in your life, always increasing. Similar thing for other type of metrics. And metrics as well can have what is called dimensions or labels, which are kind of a key value pair of values that allows you to segment or index those metrics for some specific context. Traces lives in a different world, while it looks very similar to a log, but with a very fixed schema and with a very fixed structure. So what that means, like when you have microservices, when you have applications talking to each other, they you need to correlate those requests that come from your first application to the last one, and you want to understand what's going on with every single application, right? What was doing, if it has an error or not, or what was the latency between one microservice talking to the other, what was the delay between that response, right? And traces are very well defined by OpenTelemetry, specifically by the specification. So they have a trace ID, which is the trace is like a major ID for all the transactions that happen inside the microservices. And each transaction is represented by a span. And a span is just like a log, but all of them belongs to the same trace ID. Today, Fluent Bit supports logs, methods, and traces and profiles in experimental mode. That means that it's able to transport different type of signals in very different ways to multiple places, right? So even if you're reading data from Syslog or from a Kubernetes ecosystem, you can collect this information, doesn't matter the format or the transport type, and send it out to any type of destination. Fluent Bit can be deployed on any type of environment. It could be a virtual machine, a container, a bare metal, a Raspberry Pi. And so it's very versatile in terms of like being so lightweight. You can set it together with your applications if needed to collect all the information that these applications are generating and be able to send this information out. Usually in a deployment perspective, you have multiple sources, right? And these sources, just you have the agent that collects information and send to the right destination. But as you can see in the last example, we also can send information to multiple places, not just one. So you can have multiple destinations. Also, you can have routing rules. That means that if certain data that was collected from a specific source can be routed to one or multiple destinations. Same as you can send the data from the edge directly, like in the previous slide, where you're sending from source to destination. There are different type of patterns when deploying this in production. And one of them is using an aggregation or collector mode, where you sit a Fluent Bit agent in the middle, right? And you have multiple edges sending the information to this aggregator. And this aggregator, of course, sometimes you provide more capabilities with buffering the file system. You do some processing, and then it concentrates and send the data out. There are different reasons for this pattern. Sometimes you don't have so much capacity on the edge nodes or the VMs, or they are ephemeral. They're going to disappear shortly, and you need to have long-term buffering strategy. That's why you might use an aggregator, like in this case. And as mentioned before, one of the key features here is like it to be able to be interoperable, be able to collect data from multiple sources, talk to OTLP, to Prometheus, and you can mix all of them without any problem. Okay, so now let's, before diving into traces, let's jump into the terminal for a quick demo for those who are not familiar with the project, so you can understand how it pretty much works. Okay, so what I have here is my fluentbit.yaml file, which is the main configuration file. Okay, and the way that it works is like you define what's called a pipeline, and a pipeline is composed of different components like input, processors, and outputs, right? The service section defines how the service in general Fluent Bit works, and it has different type of configuration options like the flush interval, which means how often it sends data out, because it's not like you collect and send the data. You always want to do some windows for buffering because you can optimize the network. As well, you can define the log level to be debug, trace, and so on. And also you can be able to include other configuration files in YAML or in classic configuration mode that extends other stuff. For example, in this case, I'm including a file called parses.yaml. That parses.yaml is here. That has a definition for a parser. Okay? Okay, so what this pipeline does, it has an input, just one input register here, by using the input plugin that is called tail. Tail, what it does, is just to follow or read a log file from the file system. And what it does is like every time that some application write information to that log file, Fluent Bit will detect that change and read the new data that has been added to that file. And what we're doing in addition is to parse that content that is being read inside. And how we are parsing, we're using a JSON parser that has been defined here. This parser is called JSON. So you define multiple parsers and then you just consume them. You don't need to write the parsers. Actually, our default parsers configuration has, 50 or more parsers defined that are very well suitable for most of the use cases. And just for the purpose of this demo, so we have the configuration property called read from head equals true. That means that instead of just waiting for the new data being added to the log file that we are consuming that is called mylogs.txt, well, that's pretty much, when you open the file, make sure to read from the head of the file because, we want to consume all of it because we are in a demo. Once the data has been collected, right, it goes to the output phase. There's more things in the middle like filters, processors, and so on, but it's out of the scope of this demo. And now we're just sending the information to the standard output. And we're going to open the terminal here. Okay, 1 second. I think I have this in the wrong. Okay, so here I have my configuration. And I didn't copy my binary. I'm going to copy it because I just compiled Fluent Bit. Yeah, it should be here. Oops. Here is. So we have our binary here. Okay, this is version 4.03 that is coming out this week, maybe late today, tomorrow. And we're going to run it with the configuration file that we just have here. That is Fluent.yaml. That is the same one that I have in Visual Code. So, and let's inspect what we have here. Remember this file? So this is a file that has around 25 lines, and every line is like a JSON message. What is important here is that, okay, we're going to do the opposite. We're not going to do parsing. We're just going to read the file and then see what is the output. Note that the output, we are using the stdout plugin that just prints to the standard output interface. It's a pretty basic thing. There you go. So you will see that we have the output of this here, but it looks in a format that is very similar. Well, it's the same format that we got when we defined it. How do we store the information inside the log? Where we have the timestamp, then we have the metadata. Right now, there's none. And then look at this. The content of the file has been assigned as a value to the key that is called log. Because we didn't do any parsing, we just took the raw information and just created a kind of JSON structure with it and just put it inside it. Now, to make it more readable, let's use JSON lines. And JSON lines will help us to print this in JSON. And now that it's in JSON, we're going to use JQ to print out how this information looks like. As you can see, the content of the log file is inside a key that is called log. And this is why I mentioned that parsers are important because you want to get a natural representation of the data. Now, if we enable the parser, let's call JSON and we run our example again, you will notice that now every single message is different. The timestamp has been parsed, right? We have the level of information and we have the message. That's why parsing allows you to define how the data will be decompose and structure in a new way. So this is JSON. Yeah, it's easy to see. Yeah, maybe I can and just remove this JQ stuff so you can see the output, because we were just doing a preprint. Yeah, and same as you have this, there are many things that can be done in Fluent Bit. Like while you're reading the information, you can add processors to modify the content of it. We're going to talk about that in the next office hours in 2 weeks, right? So we're going to try to do a step-by-step of how things work here. Now, this information has been sent out to the std out, right? This is just for debugging purposes, but usually in your output, you might have an HTTP endpoint on OpenTelemetry backend, like a service provided by Chronosphere or any other type of vendor. Okay, so we get back to the slides. That was for logs. And right now we're going to dive a little bit on traces, because it's a new thing that we introduced this year. And I think that is relevant to talk about it and how this is supported in Fluent Bit. And then we're going to talk about a little bit about OpenTelemetry and how Fluent Bit relates to it. Okay. So as I mentioned before, this type of telemetry signal that is called trace aims to correlate information from microservices. Okay. And the unit of that log generated by a microservice in tracing world is called a span, which has a specific schema, right? It has a span ID that belongs to a trace ID. But when you get these spans, sometimes they're very, there's a lot of information that you might not need for production, right? And usually you would like to get some samples of that information because you don't want to get 100% of it. And with just a small representation of these spans or traces is enough for your purposes of data analysis. And what we introduced this year, we already supported traces, but now we introduce trace sampling, right? And this is a well-known feature that comes from OpenTracing, and of course is available on OpenTelemetry Collector today, that allows you to do different type of sampling of data, right? Based on different type of decision. And right now, what you have in the screen, if you take a look at the configuration that we have on the left, we have the input plugin that is called OpenTelemetry that receives all TLP from applications with instrumentation or from another OTEL collector. It receives the data, and as soon as the data is received, it runs a processor for traces that is called sampling. And sampling processor has different type of backends. And in this example, we're talking about the probabilistic, type of sampling. In sampling, there are two worlds. It's like head sampling and tail sampling, right? And head sampling is basically says, as soon as I see the spans, I can take some decisions if this span will go through the pipeline or it will be discarded, right? And there are many cases. You want to say, hey, I just want to collect 40% of my spans, and that's it, right? So probabilistic sampling allows you to do that. So for all span that comes here, imagine that all of them belongs to different trace IDs. You're going to apply some basic math on it, and you're going to say, I'm going to do probabilistic and just let 40% of them to pass or be sampled, go through the pipeline. So your final spans that will be sent is a 40% of them. Okay, this is pretty simple. However, while it's simple, it does not allow you to have a very interesting, logic around it for processing. Because what happens is, like, when you are receiving traces, all of them belongs to different traces ID, and spans might not arrive at the same time when you take the decision. So how you can do kind of more complex decision based on latency or based on attributes from the traces, right? And that's why we introduced the tail sampling processor. And tail sampling, this works exactly as the OpenTelemetry trace sampling processor. The difference is that with probabilistic sampling is that this creates a window of time when we receive all the spans, right? And based on the configuration, we apply some we apply some conditions on the span, on the content of the spans, and it works in the different way. All the spans belongs to some trace ID. So internally, what it does, it receives multiple spans. You can say, like here, for example, multiple colors, right? And then it groups them, right, in the buffer, right? And once it groups them in the buffer, at some point it says, okay, I'm buffering until the decision weight, which is my expiration time. I will run my conditions and decide which spans or which traces will be sampled. And it works in this way. If one span of the whole trace matches at least one condition, all that trace will be sampled, right? We don't send individual spans. We send all of them that has been buffered. For example, in the configuration, we're doing the sampling, but in this time, we are applying the tail sampling, right? And our decision wait is for 2 seconds, just for testing purposes. For 2 seconds, I'm going to wait and buffer all these spans. And while I'm buffering them, I'm applying certain conditions. And there are 2, right? And for example, we have one latency that will say, hey, what was the latency for these spans if they are inside this threshold, right? Or at least for traces that has spans between 3 and 5 spans, right? So when you run, when it hits the decision weight, we apply these conditions, and we will find that, for example, for two trace IDs with different spans, at least one span matched the condition. And the expectation is like, when this happens, right, only these 2 trace ID, well, basically the spans, all the spans that belong to it will be sampled. So at least you can see, not at least, we see that we are discarding the last trace ID, which is F7337, because non-span matched any condition. And this is trace sampling. So for folks who are doing sampling, yeah, trace sampling, that this is a well-known feature in the Alter collector that is available from March of this year in Fluent Bit. Now, pretty quickly, we're going to talk about the relationship between Fluent Bit and OpenTelemetry, because this is the most common question that we get almost every week, right? So a quick brief. OpenTelemetry provides an open source standard for logs, measures, and traces, or different type of signals. There are more signals that are coming to the Alter world, okay? And that standard says how the schema is defined and how this data is being transferred from point A to point B. Okay, so it defines a schema for logs, meters, and traces. And once you define the schema, so a schema is, for example, okay, it needs to have this key with this value. We see something like this for logs, meters, and traces already. But once we compose this schema as data, right, this data needs to flow over the network from one endpoint to the other. And we use the protocol that is called OTLP, OpenTelemetry Protocol. So applications that get instrumented with OpenTelemetry SDKs, they speak OTLP. So what they do, they compose some data with some schema, and then what it does, it packages everything and send it over the network, right? Because application has the capability to use this SDK, package stuff, and send it out to the final destination. And this is where we fit here. So sorry, let me move this here. So we move here. We have this where Fluent Bit implements the schemas of OpenTelemetry. Fluent Bit can talk, speak, and deliver data in OTLP format. But everything else that is instrumentation, of course, yeah, it's native to your own application and how OpenTelemetry use that. So you can instrument your application with OpenTelemetry. You can use Fluent Bit as a collector for all this OTLP data. And of course, you will see that the overlap does not exist with OpenTelemetry, but exists with OpenTelemetry Collector. And from our standpoint, you can just use this technology to speak OTLP and send it to different destinations. We are fully compatible for all the signals, and I think that we align with the industry, where I think that the value, and I personally think that the value of this standardization is good. However, there's a lot of work to do around performance, scalability, because having some imposed schemas sometimes for data that is not should not be so big has some penalty when you transport that over the network, or when you want to store that or index that information in a database for analysis. What I was saying here is like, yeah, we try to be the best OTLP compatible solution for OpenTelemetry users, right? You can use Fluent Bit, you can use the OpenTelemetry collector. I think that each project delivers its own values. So we just talk about ours and how you can take advantage of that, because we know that Fluent Bit is already running in your environment. For users who are collecting data, for example, for normal systems, like reading data from the file system, from systemd, and they say, hey, I would like to get all this information in my OpenTelemetry backend. So how do we convert one data to the other? In Fluent Bit, we provide a processor that is called OpenTelemetry envelope that allows you to collect your log records and package them on kind of OTLP format, well, on envelope. So you can add resources, scope, attributes. And as well, we support modification on top of all that data. So it's not just about moving data from A to B. Fluent Bit has full capacity to process this data. And we do the same for metrics. You can collect Prometheus information from Prometheus text or remote write and apply the same envelope and convert those metrics in native OpenTelemetry format. Imagine that you can connect the old statsd protocol, take that payload and convert it to OTLP by using the same solution, the same agent, without any extra modification to your environment. And as part of some benchmarks, these are not quite new. I think there's, well, new is like they have a couple of months. We did some benchmark around what was to understand what was the performance penalty, how much we can scale between Fluent Bit and OpenTelemetry collector by reading a file, parsing the content as JSON, and just removing one key from the record, which is a very basic, right? Moving data from A to B is it will be always fast, but in the moment that you start trying to parse the data and then modify the buffer, either in memory file system, you will notice the difference. And in CPU usage, right? So we just compare vector from Datadog, Data Collector, FluentD, and Fluent Bit. I think that you will see that Fluent Bit behaved pretty decent, pretty well compared to the others, right? And standard deviations was really low, around 20%, which is really good. And here we are taking a look at how others compares for this type of load. And well, here you have some graphics for the same type of information. I know that these graphics are kind of big, but I always encourage, hey, run your own benchmark. You might have your very own use case that maybe, I don't know, other agent will behave faster than ours or will provide more value. That's fine. So this is our benchmark, but I encourage you users to run your own benchmark as well. From a memory usage, when running this test, we found that, Fluent Bit also got really stable, but we find that the OpenTelemetry collector, the standard deviation was quite low. And what that means, this is actually the fluctuation of memory usage. You will see that it is very low. And you will see that vector, there's a pattern between vector and OTL collector. I think that is the way that those languages, because vector is written in Rust, OTL collector in Go, Fluent in Ruby. So you will notice that all of them has their own specific garbage collectors. And this is really interesting because in our case, in Fluent Bit, while we try to optimize memory usage, we try to really release the memory from the priority system, from the cache, right? To optimize different type of workloads and make room for more processing, for more capabilities. And yeah, I think that languages are crucial here. They have pros and cons. This is not a language comparison, but I think that you can do things faster in any language, but you can make it really slow. And it's a matter of architecture, design, and experience. Well, at least Fluent Bit has been around for 10 years. So we have been optimizing for this use case a lot. Okay, and thanks to our community. I know that you're always around KubeCon. So if you have been around from the previous years, you might notice that these logos looks familiar. For every big release that we do in Fluent Bit, we do a new logo and we do a new t-shirt. So if you are around KubeCon, well, the next time you KubeCon US, you might be able to get, this Fluent Bit V4 t-shirt for free. So if you're a community member, you saw this video, just stop by our booth to say hi. Okay, so this has been the presentation for today. We appreciate that you're watching this office hour number 79. And I hope to see you soon in the next series in 2 weeks. Thank you so much.